All right, square. By the time we get down to square, there's very little left that needs to be done for the proofs. So the definition of a square is 4 congruent sides and 4 congruent angles that are all 90 degrees. And so I'm going to be given that it is a square. And I first want to prove that it is a rectangle. So the reality is that angle A is equal to angle B is equal to angle C is equal to angle D, because that is the definition or part of the definition of a square, which instantly tells me that it is a rectangle. Because that is the definition of a rectangle. So what does that tell me? It tells me that a square is a rectangle. Sometimes a rectangle can be a square, but a square is a rectangle. Now the other part of the definition of a square is that the 4 sides are equal. And that, my friends, is the definition of a rhombus. So what does that mean? That means that a square is a rhombus. It is a special kind of rhombus. It is both a rhombus and a rectangle kind of merged. It's like the square is the little baby child of the rectangle and the rhombus. Now, from either of these, I can state that it is a parallelogram, because that is a theorem of a rhombus, or a theorem of a rectangle. I've proven that both of those are parallelograms, so I can just do one of each of those. All right, let's do some isosceles trapezoids. So, definition of my isosceles trapezoids is one, or actually, it's the 2 legs of a trapezoid are congruent to each other. So, we'll start with our given. And our, we have really 2 things from here in terms of our definition. We have that AD is equal to BC, because that is the definition of a trap. But we also have that AB is parallel, not H, but parallel to DC, because that is also the definition of a trapezoid. So we have kind of 2 little parts there. And I want to prove that the base angles are equal to each other. So far I have these, and I want to prove that either those guys are equal or those guys are equal. So I've kind of used up this information. I can't really get anything more from that. I have the fact that they're parallel. Now, one of the other things that I have about parallel is, yes, I have that these are supplementary and these are supplementary, but I'm not really going to be able to show that these are equal to each other. I've got to somehow get some equivalence going on here. I don't have alternate interior. I don't have those types of things. Now, if I draw this here, I don't have congruent triangles either. I've just really kind of stuck here. So I think about my parallel lines again, and I say, well, parallel lines never intersect, which means that the distance in between the parallel lines are always the same. So never intersect is kind of a negative way of saying what it is. The distance being the same all the time is kind of a positive way of saying what that is. So if I draw in the 2 heights, so if I draw the heights of AE and BF, remember, you can draw heights in anything, so just make it 90 degrees. You don't know what else it does, but you know it's 90 degrees. And if I use these 2 facts, that it's a height and that's a parallel, I actually know that AE is equal to BF because of the definition of parallel, that they are always the same distance apart. So this is actually what I can say. And I also know that, let's put up the numbers in here, that angle 1 equals angle 2 equals 90, because that is the definition of height. Okay, so now that I've marked all that, so this was key. This was big, kind of figuring out a way to use my parallel lines here. I really have that these two base angles are equal to each other, because look at my two triangles. Now, it is ASS, remember I can't use that, but it's a right triangle, which means it is HL. Again, as long as these are in the same spot, these are in the same spot, and these are in the same spot, everything is good. And directly from there, I can say that angle D is equal to angle C. And that is congruent triangles give me congruent parts. And that is what I wanted to say, because those are the base angles. So I say base angles are congruent to each other. And again, why did I choose those? Those were considered the base angles. I know what those are called. Now, through continuing, these two angles are equal to each other because my triangles are congruent. These are both 90, so I can also prove that the top guys are equal to each other because technically they're also base angles. So let's go ahead and do that. I don't want to shortchange you here. So I can also say that angle 3 equals angle 4 because of congruent triangles. And I can say that this is like a little rectangle here, so what, 5 and 6. So angle 5 equals angle 6 equals 90 because of either alternate interior or whatever, so we'll say parallel lines. And if I put them together, then angle 3 plus 5 equals angle 6 plus 4 because of angle addition. And that would give me my other set of base angles that are equal to each other. So either way, this is the base, this is the base. Now both sets of those angles are proven congruent.